evening, everyone, or good afternoon, or good morning from wherever you are watching. We're very happy to have you back on board on AI Talks, part of the global AI community. Well, let's see what we're going to discuss today.
Hey, my name's Akansha Malik, and I'm from Melbourne.
Excellent Sami, it's Val here.
Hi, I'm Alan Smith.
Hi, I'm Amy.
Hey, I come from Spain.
I'm Prasant from California.
大家好，我是卢建辉
Hello, my Nederland.
I'm Fatasi from Australia.
Hi, I'm Jennifer Marsman from the United States.
Hi, I'm Aditya Gupta from India.
Hi,
I'm Matthew Renton from the USA.
I'm Joseph Isaac from California. Hi, Medin Ali Daoud from Ghana.
Hi, I'm Ana Famana.
Merhaba, ben Türkiye'den Daron Yönden.
Hi there.
Hi.
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 Okay, sorry. I had the other windows open where I could watch this stream. So we were gone for almost, for a month, for four different weeks since we had the October sessions. But now we're back today with Mauro. Hi, Mauro.
Hi, Sammy.
How are you doing there in Italy?
Yeah, it's fine.
It's
lockdown,
fine.
But fine.
I think we're all struggling with the current world conditions, and that we're all going to be happy when it's back to normal, or whatever is going to be called back to normal.
Yeah.
Mauro, please, who are you? Little presentation about yourself.
Yeah, I'm Mauro Bennici. I'm the founder of Ghostwriter AI. So it's a startup in the natural language processing world. So it means that we try to understand text, what people wrote, what people think, what people are, starting from the text that people share.
Okay, sounds very interesting. I'm sure you will share some of the knowledge of what you're using within your startup, of course, also in this session. So what is your session going to be about?
We have a little introduction about the NLP, so natural language processing, why it is important, and why this is so different from managed images, for example. And how we can use machine learning.NET to analyze text.
Okay, cool. At the October sessions, we already had some quite nice sessions around NLP with one of the co-founders of Spacey, for example.
Yeah.
But we haven't had anyone yet who talked about... We had someone who talked about ML.NET on itself, but not with NLP, combining those two. So, well, I think with that, Mauro, I will give you the platform, and we're looking forward to what you would like to share with us.
Yeah, let's start.
Yeah, you'll need to share your screen with us.
Yeah, it's starting now.
Yeah.
Okay. Just here you have my references from Twitter and LinkedIn. Please get in touch if you have any question or if you want to know more about NLP. And this is my startup. Just understand customers by conversation. Just that means that we use text or analyze text. Analyze text means sentiment, semantic search, entity extraction, pattern recognition, anomaly detection, event correlation. But what it means? What it means, read the text and understand what is the intention of people. And we are full of text. As we think about our CRM, notes, chats, email, audio clip, voice messages. Everything can be translated in text. But to share action, to can be useful for our business, we need to understand what is inside this text. In every startup or every companies, there are different parts that have to manage and cooperate. The first start from the data and for R&D. So when the data scientists create a model. The other completely different parts in when we have to put the models in production. because during the modeling, the training, we can use everything we want. We have a limited time. Not really, but generally we have a limited time. But when we go to the production, we want to be fast. And with a lot of new models and frameworks, we want to use something that we know or that the customer is able to use or can use, preferring something else as privacy, GDPR, or laws in general. So why we consider text difficult to analyze? Just imagine, when you think about machine learning or deep learning in images, we can get a piece of the images, and this piece of images can be analyzed. Analyzed only this piece of images, we can have a context. And if we put only a frame about a wheel, about the sun, this little piece of information has information itself. It's the sun, it's a wheel, it's a car. We cannot do the same for text. If I get only a word, the word cat, the cat means nothing. I can imagine this is the word to the animal, but it's not so true. And the other thing that is not easy is when we have to elaborate a text, we have to translate this text in number. So the first steps is, okay, I have the text, I have to analyze the text, and I have to translate this text as number. And I be sure that this text generate a matrix of number that is always the same. So if I analyze a text and arrive a new tweet, I have to combine this tweet with the same matrix, with the same dictionary, that the text I analyzed in my model. Because I have to be sure that the same number means the same word. I mean, if a cat is translated, for example, in other languages, as Italian or Japanese. But for humans, we have, when we speak, when we talk about something, we have context. I talk about a cat. But what happens when I see the abbreviation of the word cat? Also for the caterpillar. For us, it's simple. I read the sentence, and I know whether it's speaking about an animal or a caterpillar. And now, it's not so easy. It's not so easy at all for a machine. There is a cat inside the cat. So when we talk about analyzing text, analyze something that people wrote, we have to see a lot of more information. We have to see the language, the tone, the aspect, the sentiment, the entity, the word, but in general, the intention of the people. We can get, again, the context. I talk about soccer, I talk about election, I talk about food. And we can get to something like the location. So it's possible to understand where a person lives from the language they speak, the age of this person. Because if you are younger or old people, it's different the dictionary we use. The job is different. I use technical words in different way. My studies, what I want, my sentiment about the entities inside a text. Just imagine a review of Amazon. If I see a review when I love this product, but the shipping was terrible, what is my sentiment? The sentiment is not something about the entire review, but it's about the entities or the aspect of the review. The product is good. Yeah. And when we talk about languages, languages means a lot of things. This is some difference just to have a look from American English and British. Right, the same things that are different. The same is in every country with the dialects. So I can speak in Italian, but it's different the Italian in Turin and in Palermo. So just understand the language is important. Just another sample is Sibyl. You have to just to imagine that when you went in the ancient Roman Empire to the Sibyl, the oracle that you receive was without comma. So when you read the first sentence, ibis, redibis, nunquam per bella peribis, meaning you will go, you will return, never in war you'll perish, right? But read the second one. Ibis redibis nunquam per bella peribis means that you will die. So it was good for the oracle in ancient empire, because no one complained about, but not for us. We have to train a machine to understand this little difference. And now, just for this, we learn about GPT-3 now that is able to generate text by itself. We know about BERT, there is Elmo, there's a lot of new procedures, models, and frameworks to understand text, to process text. So when we have to choose a framework, we have to be sure that we can use everything we want. That is not a block, okay, oh, I cannot do that because I need something else. Or no, I blocked, I cannot use this because I want GPT-3 and I can use it. So when we talk about ML.NET, we can be sure we can use this technology. But we can use them on .NET Core. Just to start, just if our stack is completely .NET, we do not have to use, for example, Python on the not on the training, but for sure on the production when we deploy our model. Also because it's fast. It was completely written with the last .NET Core, so it's not Python, so it's fast. And now we can, just to start, we can see that it is a model builder that helps us to introduce the first step in machine learning.NET, just to look how it works. You can just generate a new project, a simple console. We can put on the desktop, is okay. Okay. And we are. Okay, we are simple .NET Core project. Now we can add a machine learning model. Machine learning.NET has just this pre-created models. Just to have a look, obviously text. So each check is everything is okay. And go ahead. We can select from file or from SQL Server where are our data. I can choose this one. This one is a simple data set, just to understand if a sentence is toxic or not. So here is just this test. And we have the label. 1, okay, is a toxic text. 0 is a not toxic text. So, okay, what is the column to predict? Just sentiment, the label. And what is the features? This one, we have only one feature, the text. Okay. We can want to automatically create a project. That's fine. We can start with 30 seconds of training. That is not important this moment. Is just to start to create to something, to see something as code. The builder started to create some models using more than one algorithm, selecting the best one for us. So, okay, we have on average in one versus all. The user needs to say, okay, the finish. The time expired is selecting the best one. And now it's saving the model. Okay, I selected this one because for me it's the best. It's okay. I can text the model just to have a prediction. Okay, this is reviewed and the result is correct. It's a toxic. I can add directly this on my solution as a next step. It's okay. I can deploy on Azure. I can learn how to improve this model, because obviously it was created by a template. But what we can see is the model itself. Okay, just to start, we create a context. What means is the most important things. So understanding where this text lives. Then we load our data. We create a pipeline. And we simply train the model. So we have the context, we have the data, and we have the pipeline. Just to be sure to understand better what is the training on the pipeline. The training on the pipeline is what we see in the presentation. It means transforms, so create the dictionary, so mapping our text to a number that is always the same. Featurize the sentiment text, so mapping our sentiments as label, create the trainer, predicted label, append the trilane, and just the same is evaluated, and save the model. So just remember that when we talk about NLP as algorithm, the process is always the same. We load the text. This is our train text. We transform this text and we create a dictionary. We learn, so we train with an algorithm. We save the dictionary and we save the model. When we load again this model and this dictionary, all new sentences will be translated, so transformed with the same dictionaries, as is asked to the model to predict. So calculating metrics, everything is good to start because we don't have to look immediately to the documentation, or we can start having something that works. Also, the way to consume the model is created for us. It's asked to get the path. It's okay. We create a prediction engine. So we have all the model input and the model output, not so far. The load is okay, the load of the model input, the model output are inside the models. So here, on the model strip. And the only things that we do is call the prediction. This is my input, prediction, predicted it for me. The answer obviously is the prediction and the score. So the prediction in this case is 0 and 1, but could be everything toxic, not toxic, so just a string. And we have this a score. Not just we see it in the more example. Oh, it's okay. But generally, when we are in a company that are data scientists, and this data scientist, it's difficult that they use ML.NET on generally, something that is different from Python or R. So here, normally we found something as a TensorFlow on PyTorch or scikit-learn, for example. And when these are deployed, or are deployed on the cloud, or are deployed, they use Flask on Django. So are created in Python and deployed on Python. For us to use on Java, we use .NET or Java stack. So we have to introduce another stack. Okay, we can continue to develop in .NET, it's okay, but we have to ask with web service and GRSP, it's good, but to Python services. So we have to duplicate, introduce another complexity in our deploy machines. The first idea of the ML.NET, it was to look to TensorFlow and PyTorch to understand how they work. Because TensorFlow and PyTorch, in reality, are not written in Python, are written in C, in C++, or just to say spacey, the parser is written in Rust. But they have a wrapper on Python. So the first idea is, okay, is this possible in ML.NET to write also for C# or from .NET in general, a wrapper to TensorFlow? Okay, the answer is yes. The first things done was create something inside the Microsoft ML collection to be able to load directly a model created with TensorFlow. So here we have the sentiment model, and this is a TensorFlow model. What we do is the same thing. We create a context. We load our data. Okay, this is the words. Okay, this is the ID. This is the separator. The data are loaded. We create the resign. We load the model. And now we'll be able to create the pipeline also in the same way. So I can transform, tokenize, I do the operation I did, the same that I did in the TensorFlow code. Now I transform, and now the only thing is, okay, I can fit my model. It's the same, create the prediction, and do the prediction. This is that. It works. I can run it. Now we are okay. This is the TensorFlow. I understand you're using the CPU. There is then the GPU. It is okay. This is the model, the TensorFlow I loaded. I asked to predict this question. The only things I ask to predict. The number of class. Okay, we have two classes in this way, positive or negative. Yes, it's positive. So I selected positive in this case because it's measured. Simple math here. But this was the first time. Say, okay, a lot of people use TensorFlow. I can do a wrapper from .NET to TensorFlow. But this wasn't really enough. Why? Because imagine that every time you create something about TensorFlow or PyTorch, or every new models, platforms, frameworks that become, or every new update, on the other side, this is to update our machine learning.NET wrapper to load it. It's not easy. Or something is not easy to wait. Okay, I have to wait to use the new model because I have to wait the update of the library. So all the major players on AI created the Onyx project. The Onyx project is, as written, the Open Neural Network Exchange. We can thinking about an XML from AI. When you think about AI, the output of a model is simple metrics, are simple numbers. There is the definition of the neural network, the weight of the neurons, but they are numbers. So with Onyx, it's possible to export our model from a Lot2 framework to another framework. It was the first way. Okay, I can export something on TensorFlow to be used in PyTorch. I can export in PyTorch to use on ML.NET. And this is fun, it's good. Because it means that I really can use everything I want using simple ML.NET and an Onyx data. The loading, everything is the same. What really changed is that our model is Onyx. This time, when it is okay, we have two. This format is not plus.pb as Python byte exported by TensorFlow, but we have this model on Onyx format. But it means that I have to support the Onyx also inside my PyTorch. So I have to use PyTorch Onyx to load another Onyx model. That's fine, it's okay. Microsoft introduced another runtime. So we created an Onyx runtime, which means that we can start and run a model in Onyx without to convert it again in our services. This is just the one we have on the website. But just to have a look, okay, I want to optimize my inferences. Because for Onyx, we have just exported from TensorFlow to PyTorch, but it's an export. What happens if we try to optimize these inferences? So when we have this XML for AI, just to modify to be possible to run it faster. So I can select to use on Linux, but I want C#, it's okay, the architecture. But I can use this on GPU, on CPU, on Intel math kernel library, as in this case, because I know when I want to use C#, where is the platform my machine, what is the hardware when this data will be run. This is wonderful, because also there's a lot of improvement. So just to remain on the CPU side, we can see that we pass from 6 queries per second to 111 queries per second. And generally, I did nothing. I get a model. I use the Onyx exporter. I exported this model on Onyx. And I run this with the Onyx runtime. So also the deploy of my models are easier. The data scientist team can continue to use everything they want until they are able to export their model on Onyx. My stack, when I deploy the models, all need to use to support the Onyx model, I continue to use C#. Just as we see, I can use C, Java, Python, Node.js. I don't have to change my deploy stack, my production, because my data scientists want to use a more performing and new, a better model. In this way, these are quite simple, but this is absolutely the same thing. So we are a prediction controller, so a simple C#.NET Core API. When we have a prediction within Postman, there is a combination of question and context. What means context? Context means, for example, from this example is an article. So I have an article. I want to ask a question on this article. I want the machine to extract the response for me, so the answer for me. But I'm using BERT. So I'm using BERT from the squad competition. So train a machine to understand a question and a context to answer for me. That was created also in the TensorFlow. So I get the TensorFlow. I extract the Onyx model. And now I'm able to use here on ML.NET. So I use just to say, okay, this is a model on BERT. This is my BERT model. This is my prediction. Just all to work this prediction. So if I run project, that's okay. Here we are. We have the question. I don't know if it's big enough to see. And we have a question. Where is the business receiving to go? Just send my question. Just time to load the model first time. And now I wait. It's okay. The machine have a probability of 38% that the correct answer is Moscone Center in San Francisco. So we have our BERT squad running. Yeah, fast, obviously, because the model now is loaded, but deployed in .NET Core Web API. What we can apply, this is limited. The text is everything. Just on our company, just to have really fast view case studies. We use it to analyze sales. So just to analyze phone calls. I can translate phone calls on text and analyze why something works or doesn't work. Because they use some words, because they don't use some words, because they stress something, because they look not confident, because they speak too fast, because they interrupt the other person on the call. We can improve the script because we can adapt our languages to the language that the other people talk. Generally, when we're with a friend, this is different when we of the model of the languages we use at work or with our sons. We can use it for a desk. Imagine to have all the model that you can combine your CRM, your data in the database, and the training on the NLP. Just to ask a question, it could be from customers directly in a chatbot. It could be inside an email. They arrive an email. Our machine reads this email. They understand who's the people that have to receive the email. Also, this email is important or not. Or just as a ghostwriter for marketing, just analyze the psychology of someone, understand where they live. Everything now is possible to done with the power of all the models are created from Python, that's BERT or GPT, by inside our stack in .NET. I'm done. If you have any question.
Thank you very much, Mauro. Quite an interesting talk. I had personally haven't worked myself with ML.NET, but because I thought it was just some basic stuff that you can do in it, but actually it's quite big already of all that you can even use TensorFlow in it and so on. I had no idea about that.
Yeah. Because just imagine that when we are in a very big company, the role of the data scientist use completely different stuff. So generally, we have at the beginning we have this problem.
Mm-hmm.
From the data scientist use TensorFlow. It's okay. It's a framework to do machine learning and artificial intelligence. But they arrived another team. So, okay, in this team we use PyTorch. Oh, it's okay. We are from Intel and we use the math kernel library. Okay. Now you start again to say, okay, man, we want to deploy all of them. And the problem become a reality on the IT staff people. Because, okay, man, we need a machine to the TensorFlow serving. We need a machine for the Intel Cloud API. I need a machine. So it was a nightmare. If you don't have inside your staff someone that know Python, also you have to start, okay, I have to learn Flask. I have to learn Django. So it is very complicated.
True. Well, that's the power of Onyx also. Everyone can work a little bit with their own platforms, but then once you have an Onyx model, you can reuse it anywhere.
Yeah, anywhere. This is fantastic because at the moment, okay, you can learn everything you want, but it was difficult at the start of the NX project. It was difficult with text because in text you have to clean up your text, you have to remove your stop words, you have to put a lowercase, you have to understand your entities. So it wasn't easy. Okay, I have an image. In imagine it's easy, it's bytes, I can manage. I export the model on Onyx, and on Onyx I can use. Now that we have also the BERT, the other very big transformer, everything is done in one way. Okay, I have the text. The text is automatically transformed for me on metrics, and this is applied. It was fantastic. Oh, it's wonderful. I can use IIS, I can use .NET, you can use everything you want, and we can use it now. Because in generally, it was just like, okay, Hugging Face released the first GPT-3 model on PyTorch. Okay, but on our company, we use TensorFlow. The problem is the same. So the problem was, okay, I have to switch some people on the data science team to learn PyTorch. It's okay, but now we have 20 frameworks, I think, from Cafe, from Intel, from hardware specific. So the Onyx, wonderful. The Onyx runtime is better. We can run directly with the runtime, so we don't have to import the Onyx on PyTorch.
Actually, we should even have a talk one time purely about Onyx, because I'm sure you can fill even a whole day about how to use Onyx and how to combine it with different frameworks.
Yeah, because the matter of fact now is like a database. You load the data, you ask the prediction. You don't know nothing, but it's good because I have the knowledge of what happens. It's from the data scientists. Generally, it's not from the people who wrote the API. From the API, I ask, I have the answer. The data scientist, okay, I cannot use this because you are not able to put this in production. It was a mismatch. But no, we need to create a Python web service. Okay, I don't know Python. Me too. It was the same if we use Java. We have to create something in Python that is the service about TensorFlow model. and we can ask with service. So now it's easier. Also for us, everything on us is from the stuff on deploy is .NET. We have web API on .NET.
Wow.
So it's easier to say, okay, our data system now is free to use what we want.
Whatever, yeah.
Yeah.
Well, you even have Jupyter notebooks where you can write C# code in, so.
Yeah, but the problem is scaling. So I can write a wrapper on Jupyter, but the problem is scaling.
Yeah.
Now it's funny because you can have just on a startup on NLP, we have a lot of models, but really a lot. Because just imagine we have a lot for British and one for American. It's different. There is another models that we use just to understand if people want to buy something or not. But this is completely different from the language model, the semantic model, from other people that want to buy something on Amazon. It's different. And a lot of models are fine-tuned from what they are shared from other companies. So at the beginning, 2 years ago, Facebook started to share a lot of models. Google also started to share a lot of models. Facebook used PyTorch. TensorFlow used it's invented, so used from Google. So to say, okay, how to combine them? Now I can combine them directly when I study them. Also on in Jupyter and Python. I can load a model inference directly without create a web service to pass the data through one to another. And also Onyx is very fast. It's really, really fast because it's not a binding of Python on other code, but it's optimized for the platform.
Okay. I had another question. In your first example that you were making, you were letting ML.NET pick an algorithm by itself. So you have an AutoML functionality within ML.NET.
Yeah, in ML.NET we have the functionality from just to see on the model they create as template. We have everything we wanted to start to classify something. We have everything to do a prediction about stocks. We have a lot to multiple classification, to prediction, to regression, to clusterizing. So something you can find in other Python framework as Scikit is native inside ML.NET.
Cool. For sure. I think all of us need to have a deeper look into ML.NET and all the possibilities of it.
Yeah, we have on Windows, just start with the template builder because it's easier. 2 clicks, and you have all the code. Is wonderful to start to learn. But because it's .NET, if we want a different inference, for example, on our neural network, we can just extend. In .NET, we can extend. We change
the model that you've created by the ML.NET Auto machine learning can be extended with your own services or with your own or extended or
I want a new activator for our neurons. I can see the code because it's open source, so I can also see the code of what is provided with ML.NET. I can extend, I can change, so I can have my proprietary algorithm running on ML.NET.
Okay, very cool. Nice. Do you have any platform where you say, this is a great place to start learning ML.NET?
But just everything is good, I think, because it is ML.NET. If you are on Windows, you have the template. Go to Azure because it's one click. It's just one click. You create the template, one click, you are on Azure. I use it running on Azure. This is fast. It's the fastest, absolutely.
if I'm correct, I think there's a specific web page also for it. .NET. Let me share this with the public. Yeah. So let me put here in the banner.
Yeah.
So we
direct to
have show. Okay, so this one .NET@microsoft.com/app/machine learning. There you have a full page on machine learning.net, where you have some, well, also showing the extensions with TensorFlow and giving a bunch of examples. So I guess that's a good start. Also shows the possibilities and the O2ML functionalities. So for sure, have a look on that if you want to learn more about machinelearning.net or ML.net. Mauro, thank you very much for your time, for your work on building this presentation. It was very, well, could learn a lot out of it. Some nice examples. I wish you all the best also with your startup. May it grow well as a good big company. So thank you again. Next week, we are back with another session, and we will talk about, and now I closed it, my bad. Come on.
Oh.
Give me a second. Now my computer's acting up. Always when you're going live, something needs to go wrong.
Yeah,
Okay.
absolutely. The demo effect is everywhere.
Yeah. All right. Well, actually, it's about human versus machines, but concerning emotions. So it's a bit of psychology combined with machine learning, and it will be Hakan Silvernail who will give this presentation to us. So same time, same place, of course, next week. You're all welcome to join us, Global AI Live. There you can find all the information. So thank you all for joining, and we hope to
Thank
see
you for
next
having me.
week. Bye-bye.
Bye.
Hey, my name's Akanksha Malik, and I'm from Melbourne.
Excellent Sami in Belgium.
Hi, I'm Alan Smith.
Hi, I'm Amy.
Amy, NET Turin Meetup.
I'm Prasant from California.
大家好，我是卢建辉。
Hello, my Nederlands.
I'm Mauro Bennici from Australia.
Hi, I'm Jennifer Marsman from the United States.
Hi, I'm Agatha Gupta from India.
Hi, I'm Matthew Renton from the USA.
I'm Joe Spizak from California. Hi, Mehdi Eddie Daoud is African.
Hi, I'm Ana from Canada.
Merhaba, ben Türkiye'den Daron Gönder.
Hi there.
Hi.
Hi.